All right, this video will go over the reasoning and algebra and geometry assignment that involves some proofs and whatnot. So let's start with problem number 1. It asks us to solve for b. So here we got b right here. It's this little angle right here. We do know that this angle right here is 43 degrees, and this red mark means that this angle right here is 90 degrees. If we take a look at this line right here, this is a straight line right there, which means that the whole thing has to be 180 degrees. So if this one is 90, and this one is b, and this one is 40, if I add all three of those up, they have to equal 180. So we've got 90 plus whatever b is, plus 43. That we know that has to make up 180. So now we'll simplify this. We've got 90 plus 43 is 133 plus our b value, or b plus 133, equals 180. We'll subtract 133 from both sides, and we get b is equal to 47. And there is our answer for problem number 1. You could even check to make sure it makes sense. Just, substitute the 47 back in for b, like up here, and just add them all together, and you should get 180. Or these two right here should add up to 90, since that one's a 90. So 43 and 47 do indeed make 90. All right, problem number 2. Once again, we've got this straight line right here, so we know that this right here has to be 180 degrees. This angle b plus 50 has to make 180. So b plus 50 equals 180. We call those supplementary angles, two angles that have to add up to 180. In fact, technically it's a linear pair because they form a line, they're adjacent to each other. So this is actually a linear pair which have to add up to 180. So I've got b plus 50 is equal to 180, so I need to get the b by itself, so we'll subtract 50 from both sides of the equation. We can do that by the subtraction property. And we get b on this side, and on this side we get 130. So b is 130 degrees, which makes sense because 130 plus 50 is 180. All right, let's take a look at problem number 3. Here's where they get a little bit more fun. All right. It says, given that M, right here, is the midpoint, find the distance between A and B. So since there's no line or anything above the A and B here, we know we're talking about the distance from A all the way to B. And we know that M is a midpoint. And what that means is that this length right here from A to B, so the distance from A to B, or sorry, A to M, excuse me, the distance from A to M, okay, this distance right here, has to be the exact same as the distance from M to B. So we know that AM has to equal the distance from M to B. So we know that statement has to be true. Now our goal here is to find how big the whole thing is. Well, we know that 14V AM plus MB will equal the whole thing. In fact, I'm going to write that out. AM plus MB is equal to the entire thing. I'm going to use a little red right here, so this whole thing. So from A all the way over here to B has to equal AB, okay? So we know that's the distance here plus the distance there has to equal the whole distance, okay? And we know that AM is equal to MB. So in the end, if we can figure out what AM and MB are, we can just add them together and we'll get the whole distance. Well, we know that AM is the same thing as 14V, so we'll have 14V, and we know that MB here is the same thing as 6V plus 56, and now we've got an equation. Now we can figure out what this V is, this mysterious V is, and that will help us figure out how big these lengths are. So now we're going to simplify this here. I've got 14V on the left of the equal sign. I've got 6V on the right. I cannot combine them because they're on different sides of the equal sign. But I do want to get them together, so what I'm going to do is this is a positive 6V. Let's subtract 6V from the right side of the equal sign and from the left side of the equal sign. So we're going to use the subtraction property here. 14V subtract 6V is 8V. The V doesn't go away. And then on this side, the 6V minus 6V is 0, and 0 plus 56 is 56. Now we have 8V is equal to 56. We'll divide both sides by 8. So let me just do that right here. Divide by 8, and we get this side is 1V, so 1V is equal to 56 divided by 8 is 7. So we know V is equal to 7. Now we're not done. That's not what we were trying to figure out. It's helpful, but it's not what we were trying to achieve here. So we know that V is equal to 7. Well, A to M is equal to 14V. So if we substitute 7 in for V here, 14 times 7, let me do this in a different color. So we got AM is equal to 14V. So distance from A to M is 14 times 7. 14 times 7 is equal to 98. So the distance from A to M is 98. Well, we know that AM and MB are the same thing, so this is also 98. So if you see these, A to M plus M to B, so 98 plus 98. Whoops, that's supposed to be, that's a teardrop. The 9's crying. Is equal to the distance from A to B. So 98 plus 98 is 196. So 196 there is our final answer. Sorry, we're kind of all over the board there, but hopefully you can see kind of how that problem worked out. And I showed a lot of work on this thing. A lot of this you could probably just kind of think through and do in your head. But that's the process for doing that problem right there. Problem number 3. All right, problem number 4 is very similar to what we did on problem number 3, except for instead of dealing with a set line segment, we're dealing with an angle. All right, so it says given that ray AD, so that's talking about this guy right here, this ray right here, is the angle bisector of angle BAC. So BAC, the angle bisector means that this ray right here cuts the big angle in half. Okay, so we know that this angle right here and this angle right here, whoops, that's not what I want to do. Meant to have green, not white. It's hard to see white on a white background. So these two angles, this blue angle and this green angle that I've marked, they have to be the same size. And similarly how we have marked over here, if I add those two angles together, it has to give me the measure of the whole angle. Okay? So the blue piece plus the green piece equals the red piece. Our end goal here, though, is to find the measure of angle DAC. So D to A to C. So the green angle. We're trying to find the green angle here. That's our end goal. All right. So we know if we need to come up with some sort of equation. We've got to figure out what K is. And so to solve for K, we've got to come up with an equation, something that is equal to something else. It's what we did over here on this one. We needed to find V, so we needed to come up with some equation. So we decided that, hey, 14V had to equal 6V plus 56, since M was the midpoint and these had to be the same size. Well, we're going to do the same thing over here. This blue angle has to be equal to the green angle because this ray AD is a bisector. So let's say that 4K has to equal K plus 18. K plus 18. And now we've got an equation. Now we can solve for K. And once we know what K is, we can plug it into this equation right here, this K plus 18, and take whatever it is, add 18 to it, and we'll get our answer. So let's solve this thing. We've got 4K on the left, 1K plus 18 on the right. We cannot combine these two terms. They're on different sides of the equal sign. So we need to move one of them over to the other side. And usually, typically what we'll do here is we'll move this K over here. So we're going to subtract K, or subtract 1K. Subtract 1K from both sides. 4K subtract 1K is 3K. 1K subtract 1K is 0, and 0 plus 18 is 18. Now we've got 3K is equal to 18. We need to get the K by itself, so we will divide by 3. And that 3 divided by 3 is 1, so we have 1K is equal to 18 divided by 3, 6. So K is equal to 6. So now we know how big K is. Remember, our goal here is to figure out the measure of angle DAC. So our end goal is not finding K. It's important, but it's not our end goal. So we're going to plug 6 in for K right here. So we're going to have 6 plus 18. That's the measure of angle DAC. In fact, I'll put measure of angle DAC is equal to K plus 18. We know K is 6. So 6 plus 18 is 24. So the measure of this angle right here is 24. Now we could check that just really quick. If this is 24, this angle, the blue angle, should also be 24. Well, if K is 6, we could plug 6 in for K. 4 times 6 is 24. So we did it just fine. All right, let's take a look at problem number 5. kind of encroached a little bit on our workspace over here, but that's okay. All right. Question, solve for x. We got to figure out what x is. So these are going to be kind of similar to what we just did up there. We've got the distance from K to L is equal to x plus 21. The distance from L to M is equal to x plus 13. The whole thing has to be equal to 12. So if we take, this is the segment addition postulate, if we take this green piece plus the red piece, it's going to give us the whole thing. So we're going to have x plus 21 plus the red piece, x plus 13. We know that that has to equal 12. And now we can just solve. So now notice on this one, I can combine like terms over here. They're on the same side of the equal sign. So I have this x and this x I can combine. So I have 1x plus 1x gives me 2x. 21 plus 13 is 34 equals 12. Now we want to try to get the x by itself. So we got to get rid of this positive 34. So we're going to subtract 34 from both sides. So I'm going to minus 34, minus 34. So over here we got 2x. 12 subtract 34 is negative. So this is going to be a negative answer. Negative 22, right? Can I do math today? I think so. So now we got 2x is equal to negative 22. We'll now divide both sides by 2 to get rid of that 2. And we get x is equal to negative 11. And there's our answer right there. We could check it if we wanted to. It's kind of weird that our x is negative. Remember, it doesn't have anything really to do with the lengths. It's just how to find the length of KL or LM. So if we plug in negative 11 up here, that's going to make this 10. Negative 11 plus 21, or think of it as 21 minus 11, is 10. Negative 11 plus 13 is 2. 10 plus 2 is 12. So that is the correct answer. All right, let's take a look at problem number 6. It's going to be done very similarly to, in fact, basically the same thing as problem number 5. So we've got the distance from I to H is x plus 4. The distance from H to G is x minus 2. And we know the whole thing has to equal to 10. So we're going to have this piece, the green piece, x plus 4. We are going to add it to x minus 2. And that has to give us a value of 10. So on the left-hand side, these are all on the same side, so we can combine them together. X plus x is 2x. 4 minus 2, or 4 plus a negative 2, is positive 2. And then on the side we have 10. Well, we need to move this 2 over, so we'll subtract 2 from both sides. So we get 2x is equal to 8. And we will divide both sides by 2. And we get x is equal to 4. Once again, we could check our answer if we wanted to. We could plug 4 in for x. 4 plus 4 is 8, so the green piece is 8. 4 subtract 2 is 2, so the red piece is 2. And 8 plus 2 is 10. So we did it right. All right, let's take a look at problem number 7 and problem number 8. We'll look at 7 first. But 7 and 8 are going to be very similar to 5 and 6, except for instead of segments, it's just they're angles. So let's see what we got here. We've got the measure of angle. In fact, I'm going to highlight this. So measure of angle CDE. So that's C to D to E. So that's the big angle. Is 2 plus 4, 44x. The measure of angle CDK. So C to D to K. That's the small angle. Is 42 degrees. And the measure of angle K to D to E. So K to D to E, that's that little angle right there, is equal to 23 plus 2. So we need to find x. So somehow we need to come up with an equation that involves the x with something equal to something else. And if we look at this picture, we can kind of see this through the angle addition postulate. The blue angle here plus the red angle will give us the green angle. So let's write that out. So the blue angle, that's the angle CDK. So the measure of angle CDK is 42. So we're going to have 42. That's the measure of the blue angle plus the measure of the red angle, KDE, so this guy right here, 23x plus 2. That has to equal the whole thing, right? CDE. So CDE is 2 plus 44x. And now we'll just solve. So on the left here, we can do a little bit of combining. 42 plus 2 is 44. So we're going to have 23x plus 44. On the right side, can't do anything. This doesn't have an x, this does. So I can't combine those together. But what we can do now is let's get our x's on one side and our not x's on the other side. So personally, I like moving my x's over to the left usually. And on this one, I think that's probably an okay idea to do. Actually, you know what? This 44 is bigger than 23, and I'm lazy, so I don't like subtracting a bigger number from a small number. I'm going to move this guy over. I'm going to move 23x over to this side. Okay, so that goes out. Those cancel out. So now I have 44 is equal to 2. 44 subtract 23 is going to be 21. And now we'll subtract 2 from, well, I'll move him over, so I'm going to subtract 2 from both sides. So that gives me 42 is equal to 21x. And now to solve this, we're going to divide both sides by 21. And we get 42 divided by 21 is 2, and 21 divided by 22 is 1, so 1x. So our answer is 2. And we could double check that if we wanted to. We could plug 2 in for the green one. So 2 times 44 is 88. Plus 2 is 90. So the big angle is 90. So the other two should add up to 90. So this one is 42. So for the red one then, if it adds to 42 to make 90, it's got to be 48. So let's see. If we plug in 2 for 23x, so 23 times 2 is 46. 46 plus 2 is 48. So 48 plus 42 does equal 90. This is the correct answer. All right, problem number 8. So same idea here. We've got the measure of angle WVU. We'll mark that one. WVU right there is equal to negative 10 plus 9x. Then we got the measure of WVR. So W to V to R is 44 degrees. And we've got RVU. Whoops, I forgot to underline that one. I'll go back. RVU, so that's that guy, is 3x plus 12. Let me underline this one in blue so we remember it. We just want to find x. So once again, we got to come up with an equation. So something is equal to something that involves that x value. And we can see from this picture, the red angle plus the blue angle equals the green angle. So the red angle, 3x plus 12, plus the blue angle, which is 44 degrees, that has to equal the green angle, which is negative 10 plus 9x. So there's our equation. This is equal to that. That is a true statement. It didn't matter if we put the blue one first or the red one first. It's all the same thing. The blue plus the red is equal to the green. The red plus the blue is equal to the green. Doesn't matter. On the left here, let's see what we can do. We've got a 3x and no other x's, so I can't do anything with that 3x. So we'll just copy them down. 12 plus 44, I can combine those together, and that gives me 56. On the right here, I've got a negative 10 and I've got a 9x. I cannot combine those together. They are not like terms. Whoops. I just said the word like, and it reminded me of the letter K, and I almost wrote the letter K. There we go. 9x. Okay, so now we want to get the x's on the same side. On this one, I move the x's over to the right. Let's move the x's over to the left on this one, just for fun. So I'm going to subtract 9x from this side, 9x from this side. I can combine these two terms together. I can't combine it with the 56, but I can combine these two together. 3x subtract 9x is negative 6x plus 56 is equal to a negative 10. Those cancel out. Got to move the 56 over, so I'm going to subtract 56 from both sides. So over here I'm going to be left with negative 6x, and over here I've got negative 56 minus 10. That's minus 66. So now I'm going to divide both sides by a negative 6. A negative divided by a negative is a positive. So this is going to leave me with positive x. Negative 66 divided by negative 6 is positive 11. And you could check to make sure that answer makes sense. If x is 11, the big angle is going to be 9 times 11, which is 99, minus 10. So the big angle is 89 degrees. Well, if the blue angle is 44 degrees, and the blue and the red have to add up to 89, that means the red angle should be 45. Right? 45 plus 44 is 89. So let's see. If we plug 11 in for x here, we get 33 plus 12 is 45. So we have the correct answer. All right, let's come down here to 9, 10, 11, and 12. It says, name the property that justifies going from the first statement to the second statement. So let's see on number 9. So we say that the angle M is congruent to angle L. That means they're the same size and shape, okay? And we know that L is congruent to angle P. So how can we therefore say that angle M and angle P have to be the same size? Well, if you look, if M and L are the same, and L and P are the same, well, doesn't that mean M and P are the same? That is the transitive property. Transitive, well, there's too many I's there. Transitive. That's the transitive property right there. If A is equal to B and B is equal to C, so if A is equal to B and B is the same thing as C, then A and C must be the same. That's the transitive property. Okay, problem number 10. We have 2x plus 8x plus 1 is equal to negative 9. And now we say that 10x plus 1 is equal to negative 9. So let's see what's changed here. The negative 9s have not changed. The plus 1s have not changed. So something's happened with these right here. As we look at that, 2x plus 8x is 10x. So if we combine like terms, we get 10x. So we can say combine like terms. That would be an acceptable answer. That's kind of like the better answer. Combine like terms. But if you wanted to say simplify, I would say simplify is also a legitimate simplification. I would say simplification is also a legit step. You could call it either or. Combine like terms probably better, but simplification would also definitely work for problem number 10. All right, problem number 11. We've got 5x plus 7 equals 13, and then magically we turn into 5x equals 6. So let's see what's the same. The 5x's didn't change, so let's not look at that. Somehow we've gone from a positive 7 on the left and a 13 on the right to a 6. And so we got to get rid of that 7, it looks like. So what they've done is they've subtracted 7 from both sides. Okay, 7 minus 7 is 0, and 13 minus 7 is 6. So what property allows us to subtract the same number from both sides of the equal sign? That is the subtraction property. As long as it's the same number that we're subtracting from both sides, we can subtract whatever we want. All right, problem number 12. We've got 3x is equal to 12, and then we get x equals 4. So both things have changed here. Looks like to go from 3x to x and 12 to 4, the thing they have in common is we are dividing both of those by 3. 3x divided by 3 is 1. 12 divided by 3 is 4. So what allows us to divide both sides by 3? That is the division property. As long as we divide both sides by the same number, and that number is not 0, you can't divide by 0, then that's allowed by the division property. All right, problem number 13. Let's take a look at this one. Ooh, an explanation. That looks like fun. Okay, explain why the statements AB, that's line segment AB, is congruent to line segment BA, and why angle XYZ is congruent to angle ZYX. Why are they both true by the reflexive property of congruence? Well, let's take a look at what these objects look like. So if I have a line segment AB, when we write out line segments, it does not matter what order they go in. Line segment AB is the exact same thing as line segment BA. That's why this is congruent. So the reflexive property says, hey, for some things, not all things, but we can switch around these terms. So instead of listing the A first and the B second, we can switch around the B. We can switch it around to the B first and the A second. Okay. Angles work the same way. If I have angle X, Y, Z, okay, this angle is the exact same thing as angle ZYX. The important part is that the vertex Y is in the middle. After that, it doesn't really matter. So once again, the reflexive property says that we can switch those around and we still get the same picture. We just named it something differently. Okay. One really quick thing, if I had ray AB, if I try to do ray BA, those two things are not congruent to each other. The reflexive property doesn't work unless you also reflect the arrow around. So for example, if I have ray AB, so there's my ray A to B. ray B to A would be this, starting at B and going in the direction of A. That is not the same thing. So if we did the reflexive property here with this, we would have to say, so that's not true. That is not congruent. But AB is congruent to ray like this if we write our arrow in the other direction. So if we reflect the arrow as well. So just keep that in mind. Because the bar up here is, is symmetrical like that, it doesn't matter. But if we did array, it would be. So what would you put on this? I mean, as long as you've got like a picture, basically the important part is that you understand this. Is that segments, it doesn't matter which way you write them, A to B or B to A, it doesn't matter. The angles, it doesn't matter if it's XYZ or ZYX, as long as the Y is in the middle. But the reflexive property allows that to be true. So as long as you understand that, whatever you put for a picture, know that. And then know if you're dealing with array, where it's important which one is the endpoint and which one it's going in the direction of. As long as you switch the arrow, this looks a little weird, but I guess that's still legit. As long as you switch the arrow, the direction of the arrow, then you're just fine as well. All right, now problem number 14. It says complete the proof. Yay, we love proofs. Now it's already been kind of completed for us. That's kind of nice. We just have to kind of fill in the blanks here. All right, so let's get familiar with the problem. It says given M is the midpoint of segment AB. So M is right in the middle of AB. Okay, I'll buy that. We want to prove that X is equal to 3. So the very last statement we'll make is X is equal to 3. Okay. We know M is the midpoint of A to B. Okay. And we know that because it was given to us. That was supposed to be a G, not a 6. I don't know where I was going with that. So that was given to us. That information is given. It says right there. Okay. So how can we now say that AM is congruent to MB? So what reasoning in math allows us to say, hey, this segment right here is the same size as this segment right here? And if you look at your note sheets, on the bottom of the one that has reflexive property on it, the second to last one, it says definition of a midpoint. Okay, because this is a midpoint, M, that means that A to M and M to B have to be the same. They have to be congruent to each other. So the way we can say that is definition of midpoint. That's what allows us to say that. If this wasn't a midpoint, we could not say this. Okay, but the definition of a midpoint allows us to say that this side has to be equal to that side. Okay, cool. So now notice all that's happened here is we've gotten rid of the lines here and gotten rid of the little squiggle. So this is saying the segments are congruent. They are the same size and shape. This is saying, hey, the distance from A to M has to equal the distance from M to B. And that is true. We get because congruent segments have equal length. Okay? Congruent segments, by the definition of congruence, is basically what this is. If two things are congruent, they have the same size and shape, or they have the same length. Okay, so we don't have to do anything there, but it's just good to understand what's going on. All right, now we've gone from AM equals MB to 4x equals 2x plus 6. So we know that AM is equal to 4x. We know that M to B is equal to 2 plus 6. That's actually given information. We probably should have put that up here, but that's okay. But if we look at this, how can we go from this statement to this statement? Well, if AM is the same, if AM is equal to 4x, that is a true statement. That means they're interchangeable. We can replace one with the other. So I've replaced AM with 4x, or another word for replace is substitute. Substitution property. We have substituted 4x for AM, and we substituted 2x plus 6. Oh, there's not an x. We're missing an x. That's a problem. That's a typo. 2x plus 6. We're substituting that for M plus B. All right, so now, this is kind of tricky. What's the next step? Let's see what they did. They did a subtraction property. So to get to the next step, what has been done is a subtraction property. So let's think through this. How would we want to simplify this? If we subtracted 6 from both sides, that's not really going to get us anywhere. We want to try to get the x's on the same side. So let's do this. Let's use the subtraction property, because that's what it tells us to use. Let's subtract 2x from both sides. So I'm going to do the work over here. So 4x is equal to 2x plus 6. So if I use the subtraction property to subtract 2x from both sides, I get 4x minus 2x, which is 2x. 2x minus 2x is 0. and 0 plus 6 is 6. So we're left with 2x equals 6. Now our next move, somehow we get to x equals 3. We have to decide what move that is. Looks like we've divided both sides by 2. And the property that allows us to do that is the division property. And now we have proved that x is equal to 3. There's our statements, that's our work, and here's our reasonings why. X is equal to 3. All right, let's take a look at problem number, 15. We're jumping all over the place. All right, 15, here we go. That's good right there. All right, given EG is equal to 5, we want to prove that V is equal to -1. And if we look at the proof down here, all the steps have been done for us. Now we just have to come up with the reasons why we can do all this stuff. So let's look at the first thing here. We've got, oh, by the way, we have this segment right here. So it looks like the distance here is 2V plus 3. The distance here is 4V plus 8. We have E, F, G, okay. So statement, the distance from E to G, that's what that means. No bar or anything. So this is the distance from E to G is 5. The distance from E to F is 2V plus 3. And the distance from F to G is 4V plus 8. What allows us to say that? Well, we don't have to prove it. We don't have to prove that EG is 5. How do we know that this is true? Because it was given to us. We don't have to prove that E to F is 2V plus 3. Why do we know that? It was given to us. This is all of our given information. All right, now the next step says that we take E to F, the distance from E to F, plus the distance from F to G is equal to the distance from E to G. So it's saying essentially this distance right here, E to F, plus this distance right here, F to G, is equal to the entire distance, EG. What allows us to say that? Little segment plus little segment equals a whole segment. That is the segment addition postulate. That's a favorite one for when you're dealing with segments. All right, now what have we done here? We've replaced EF with 2V plus 3. We've replaced FG with 4V plus 8. And we replaced EG with 5. What property allows us to say that? Well, EF and 2V plus 3, they are the same thing. Same thing with FG and 4V plus 8. They are equal to each other, and EG is equal to 5. So we are allowed to replace them with each other by the substitution property. All right, let's see what's gone on next. Here we've got this stuff, and then we end up with 6V plus 11. Well, I can see where the 6V came from. Let's see, 2V plus 4V is 6V. 3 plus 8 is 11. So what we've been doing over here is we've been combining like terms. So we combining like terms. Or if you put simplify or simplification, I think that's a valid answer as well. Simplification. I think combining like terms is probably a little bit better, but simplification also works. All right, next step. We got 6V plus 11 equals 5. And now we jump down here to 6V equals a -6. So let's see what's changed. The 6V didn't change. It's this 11. It disappeared, and somehow we got -6. And if you look at that, if we subtract 11 from both sides, 5 subtract 11 is -6. So what property allows us to subtract 11 from both sides? The subtraction property. And finally, we got 6V equals -6. What allows us to go from there to V equals -1? It looks like what we've done is divided both sides by 6. And in fact, that's exactly what's happened. And what allows us to do that? The division property. And that does that proof right there. We've now done all the reasons for the proof. They gave us the steps, we gave the reasons. All right, let's take a look at problem number 16. All right, looks like my canvas wasn't long enough, so let me just paste this in here. So edit, paste, nope. So here's 16 and 17. Let's make sure we got those on the, technical difficulties. There we go. Okay, problem number 16. Once again, a proof. We've got the measure of angle BAC. So angle BAC, so that's the big angle. So this guy right here is equal to 104. And we got that written right there. We also know that the angle BAD, so this guy right here, is equal to 20x plus 7. Okay, so that's the green angle. The blue angle. And then we've got angle DAC, or CAD, they put CAD, is 6x minus 7. Our goal is to prove that x is equal to 4. So this problem is very similar to some of the ones we've done earlier. I think it was like 7 and 8, except for we have to actually show the proof, why we're doing it. So here we've got all the things that we know listed. That's the given information. Now the question is, how are we going to go about solving that x is equal to 4? Well, kind of going back to what we've done on some of the other problems, we know that if we need to come up with an equation to solve for x. We need to have an equal sign, something on the left, something on the right, and they have to be equal to each other. So we look at this picture, we can tell that, see here, that the green angle plus the red angle is equal to the blue angle. And what allows us to say that, if you remember, is the angle addition postulate. So let's write that out. Let's write exactly kind of what we know from that angle addition postulate. We know that the measure of angle BAC, so measure of angle BAC has to be equal to the two littler angles added together. So the measure of angle BAD plus the measure of angle CAD. There's the angle addition postulate. That has to be true because of the way this is built. Okay. Now that we have this written, let's replace it with some numbers and x's and stuff, all the information that we have. So we're going to replace or substitute measure of angle BAC for 104. We're going to substitute 20x plus 7. So 20, let's do that in green. 20x plus 7 for the measure of angle BAD. And we're going to substitute 6x minus 7 for the measure of angle CAD. 6x minus 7 for that. And what allows us to do that? The substitution property. All right, so now let us do some combining like terms. Let's simplify this thing up a little bit. On the left, there's nothing I can really do, so that's still 104. On the right, though, I've got 20x plus 6x. That's 26x. I've got a positive 7, subtract 7. That's 0. They just go away. All right, so what allowed us to go from this step to this step? We combined like terms, or if you put simplification, that would be acceptable as well. Simplification. And then finally, we take a look at this thing. I need to get rid of the 26 as being multiplied to the x, so we'll divide both sides by 26, and 104 divided by 26 is 4. So we use the division property. Perfect. Boom. Done with problem number 16. One thing you could do to check your work is just make sure it flows, that you're not using any information just make sure that it flows. You can't tell, but I'm pointing at it with my hand. Anyways, make sure that the whole thing flows and the reasons all make sense. It's one thing you could do to check your work. All right, our final problem. Here he is right here. Our very last proof. Notice that nothing is filled out this time. So here we go. Given line FH. So it is telling us that from F to H is a straight line. Okay, that is a straight line. Now, what else does it give us? So it also tells us here, based on the picture, that angle FGJ is 3x. So I'm going to write that down here. A measure of angle FGJ is equal to 3x. And the measure of angle JGH, right here, the measure of angle JGH is 6x. And then it tells us that f of h is a line. Okay? All of that is our given information. All right, so now what do we do with it? Well, because FH is a line, the whole angle here has to add up to 180. Okay? In fact, we probably should say that the measure, and I don't know if this might be an extra statement in here, so we might need to add an extra box on here. But we probably ought to say someplace that, hey, the measure of angle FG, in fact, let me draw this in green since that's what I used before. The measure of angle F to G to H, F to G to H equals 180 degrees. And why do we know that? This might not be a reason on our list, but we know this is 180 because that's a definition of a line. Definition of a line. A line measures 180 degrees, right? So that might be an extra step. I'm going to throw it in there anyways. We might have to add an extra box at the end. All right, well, if FGH equals 180, okay, we now know that the red angle plus the blue angle has to equal the green angle. So we do know that the measure of angle FGJ plus the measure of angle JGH has to equal the measure of the green one, measure of angle FGH. And we can say that by the angle addition postulate. The little angle plus the two little angles added together equal the big angle. That's in a nutshell, that's the angle addition postulate. So now what we can do is we can substitute. We know that the measure of angle FGJ is 3x. We know that the measure of angle JGH is 6x. And we know that the measure of angle FGH, we didn't know, this is why I said we probably should put this in here. It's kind of given, but it's at the same time it wasn't explicitly said, so it was probably good to just make mention of it, that the measure of angle FGH is 180. And what did we just do there? We substituted values in, so that was the substitution. Substitution property. Now we can take a look at this and say, hey, 3x plus 6x is 9x. 9x equals 180. So what have we done there? We combined like terms. Or if you put simplify or simplification, that would work too. And then, like I said, because we added this one in there, we do need to add one more box. We're going to divide both sides, which is fine. I mean, you have a whole bunch of boxes. You could have put each of these givens in its own little box. It doesn't matter. As long as you got all the parts there. So let's see, we're going to divide both sides by 9, it looks like. So x is equal to 20. And we're able to say that because we're dividing both sides by 9. That is the division property. And there we go. We have now proven that x is equal to 20.